And we have the opportunity to introduce today Suprabha Mysore. She was also a part of yesterday's webinar session with Nalina Jain. And let me quickly introduce Suprabha. Suprabha is she is the Senior Program Manager Android Enablement Intel APAC. She has about 16 years of industry experience that spans across telecom, datacom and mobile technologies. In mobile technology, she has worked on location-based services frameworks, NFC and Wi-Fi stack for both Symbian, S40 and Android platforms. In her 16 years of career, she has worked in different roles of software engineer, tech lead, software development manager, senior manager, and program manager. Currently at Intel, she is the senior program manager, as I already said, for Android in APAC region, handling and owning Android application enabling vision and roadmap. With Suprabha, we will have today Dushwant Singh as well as Nalina Jain, who will be taking in the questions at the end of the session. Suprabha will be taking us through her presentation for the first 40-45 odd minutes, and then we'll be opening up the session for questions. I now hand over the session to Suprabha. Over to you, Suprabha.
Thanks, Sri Lagna. Good afternoon, everybody. Today I will be covering the topic of develop, optimize, debug, and tune your Android apps. So even before I start talking about why you should optimize or tune your apps, let me give you a brief. The picture is not coming. Picture is not coming. Sorry about this one. So it looks like the picture is not visible over the webinar anyway. So the message that I had here is there are numerous options of different computing devices to consumers today. So gone are the days when computers meant the Dells and the HPs, and the operating systems meant the Suns and the Microsoft OSs. So there are numerous options. So we have the who's who of the computing world in the mobility business today. So if you look at it, there are major brands like Microsoft, Android, rather Google, Apple, having a big play in the mobility industry today. And we have numerous OEMs and ODMs bringing out their devices based on these software systems or software platforms. And there are numerous hardware vendors as well, Intel being one of them. So really the choice of devices, the choice of software today for the consumers is plenty. So that kind of also creates opportunities for the developers. So there are plenty of devices which really calls for multiple applications on these devices. And it's no longer a solo play of the devices alone. So it's a complete ecosystem play today. And then the ecosystem involves the hardware, the software, the applications, the user experience. Everything put together is what forms a computing experience, as we call it.
Suprabha, I'm sorry. Suprabha, hi. I'm sorry, just quickly
Sure.
interrupting you. If you could put the microphone really close to your mouth, because I feel there's a little disturbance and the voice is breaking up a little.
Is this any better? I'm very close to the mic right now.
Okay, all right. Just make sure that the other audio settings are I can't make out as yet. Maybe how about you keep an eye on your chat window? If I feel there is any further disturbance, I'm going to let you know on the chat window.
Sure, Srilagha. Thank you. Okay, so let me continue. So what is it that is being displayed on your screens right now? This is a bitmap of all the different applications that are available in app stores today. So somebody has really taken an effort to put together the logos of different applications that are available in different app stores. And if you look at it, this is how cluttered it is today. So if you take Google Play alone, Google Play itself has more than 1 million applications today. So if each one of us are application developers, we also see the kind of competition that is posed to us by these numerous apps that are available in the ecosystem in the mobility world. So what is it that we need to really focus on moving forward or to stay in this developing mobility app economy? We are all developers. We know that we need to develop feature-rich, functionality-rich, good applications. We also need to take care of finding the appropriate distribution channels for our applications. It's just not sufficient that I develop a real cool app, but I need to find a channel through which I really provide it to the world. And like we spoke earlier, there are numerous software platforms, hardware platforms that are available today. And being a developer, my focus, at least personally, I feel that I would want to develop cross-platform code that I can seamlessly run on different hardware and software platforms. So if you look at HTML5, the whole evolution of HTML5 is based on the premise that developers would want to develop one piece of code and run it across different platforms, be it software platform, hardware platform. Given the numerous applications that are available today, it's very, very important that we differentiate our application from the others or the rest of the applications in the same segment. So if you go to Google Play or any app store for that matter, if you are looking for a particular category of application, especially in the entertainment space, in the gaming space, you will find similar apps that are there in plenty. So as a consumer, or how do you get the eyeballs of the consumer onto your application? That is basically through differentiation. So these are certain fundamentals of what we need to focus on as developers. But to me, at the core of all this, what lies is productivity. Take any top downloaded app or top grossing app in any of these app stores. You will find a pattern there. These top apps typically, they do whatever they do it very well. When I say that, there is a lot of efficiency in the way these apps behave as compared to the apps that are not doing very well in the same category. So it is very important for me as a developer to be equipped with tools and infrastructure, development infrastructure that can help me do my applications or make my applications in a very, very productive and an efficient manner. So I will introduce you to some of these tools today that can really help us develop our applications in an effective way. So let's take the first example, which is the Intel Hardware Accelerated Execution Manager. Rather than running through these different words in the slide, let's go to you can see on the screen, I just opened the Android virtual device manager, and here I have created two virtual devices. One is simple other, as I call it. The other one is simple x86. So both of these result, when I click on start, both of these result in opening of emulators. So you should be able to see two emulators on your screen right now. So you can see the titles as well. There is simple other and there is simple x86. If you observed, even before these emulators opened up, there was a message on the console that the virtualization manager or the HAXM has kicked in for the Intel simulator. So the result of the HAXM getting kicked in is what you see on the screen right now. So you see a clear difference in the time that it has taken for these two emulators to come up. The Intel emulator or the x86 emulator has really come up faster as compared to the other one, which is not Intel based. So what is this hardware execution manager all about? This is a software tool which is based on virtualization technology, or Intel VT as we call it, and this is the one that is actually speeding up the starting of the emulator on our Windows machines. This is available. Let me show you how can you see it.
So Prabha, just quickly wanted to check if you have checkmarked the telephone option in audio.
Yes, it is marked, Srilagna.
Okay, because a lot of our attendees today, I think they are having slight difficulty with the audio.
Should I redial in that? Because they're using exactly the same phone that we used yesterday for the
Right,
presentation.
right.
Should I redial it?
No, how about we wait for another 5-7 minutes and then we can take a call. You can continue with your presentation.
Sure. So you see the Android SDK manager on your screens right now, and there are few extra things that there are few Intel x86 related components that you see here. So first one is the Intel x86 Atom system image. So you can see that on the different Android versions out here. And then if you scroll down under extras, you can also see the Intel x86 emulator accelerator, HAXM, that is also installed on my machine. And this is what was primarily responsible for the emulator pertaining to x86 come up fast. Okay. So now I talked about a particular tool that will really help you develop applications in an effective and an efficient manner. Now, after you have developed your application, the first step, at least I would like to take, is to see if my application is really built or coded efficiently. So even for profiling your apps for its efficiency, Intel has a tool which is called Intel Graphic Performance Analyzer. So let me open that tool again to show you This is just to show you how this works. So I am connecting to the emulator that I have already opened. This is specifically again designed for Intel platform. So you can see that there is a list of applications that you can profile. So let me take an example application here. So when I clicked on the speech recorder, which opens here in, there was a delay, looks like. The speech recorder has come up here. And what happens next is what you can see here, that a system analyzer comes up for that particular application, and there are different parameters that you can profile your application against. Let's see and try and go back if we have. This is actually taking longer than what is anticipated. Let's get back to the file. So what you see subsequently once the GPA or the graphics performance analyzer connects to the device is a screen that you see on the left-hand side of the slide. So like I said, there are various parameters like CPU usage, disk read write. You can drag and drop each of these onto the right-hand side and see how much of CPU utilization is being done for a particular operation that you are doing within your application. Similarly, you can see that there are intense disk read, disk write kind of activities that are happening in your application. And if you can also identify what are all the pain points or the lines of code in your application that are really causing too much of CPU load, and this will help you really nail down on those pieces of your application where you will have to focus your optimization efforts on. So how do we go about getting this system analyzer? You just have to install the, how do we go about using the system analyzer with your application? Install your application APK onto the device, onto an Intel-based phone or a tablet Android device. Run the Intel GPA on your development machine, and then you can start profiling it for different parameters. Not just that, so this is something that I've already spoken about, the different parameters against which you can collect the data. There is also a facility for you to really collect all this information in a spreadsheet or a CSV file as well. So there is a CSV button on the, I think I should just go back to this. System view is still taking time. Anyway, so there is a CSV button. You can see that here on your screen. So if you click on that, all the numbers profiled against your application are actually exported onto a spreadsheet, and you will be able to collect these numbers at different, or you will be able to collect different snapshots with different operations on your application. So where do we use this GPA? Typically, it is if you have a graphics intensive application, you can analyze it to see what part of your code you can offload to the GPU. So this is one of the best uses of GPA that we have seen with some of our partners. So this is a snapshot of a CSV after we have exported it from GPA. So now, just profiling of applications is not good enough. We will also have to see how can we go about optimizing it. So even for that, we have a tool. It is called Intel Integrated Performance Primitive, or Intel IPP for short. What is this Intel IPP all about? Intel IPP is, you can essentially say, this is just a library it will provide you with building blocks for different operations or activities like image processing, signal processing, multimedia, speech recognition, computer vision, video playback, and so on and so forth. So this is essentially a library, so you will really have a .a file that you will have to include in your app. But the point to note here is, to use Intel IPP, your application has to be an NDK application. You have to really be coding or using NDK or the C, C++ based libraries in your application to be able to receive optimized functions with your code. Let's go back to Eclipse and see how do we go about making an app an NDK app. So this is something that Nalina has covered in her webinar yesterday, but I will just run you through this again. So I have two sample applications here. You can see that there is a Hello IPP simple. This is the one that is actually making use of different function calls in the IPP library. But I have created Hello World example. This is just a Hello World application, which is right now not an NDK application. I will just show you how to make this or how to turn this application into an NDK application. So you just have to right click on the project in Eclipse and then go to Android Tools and click on Add Native Support. So this is the simple step required to make an application an NDK application. So this is an operation that has already been done for the first project that you see there, which is the Hello IPP simple app. So if I go to Android Tools here, you no longer see the activate in native support here. That is because it has already been done onto this app. So now how do we go about using the IPP functionality within our code? So once you actually create or turn an application into an NDK app, the first thing that you will see is inclusion of a folder by name GNI. So this is the interface folder for you, or this is the one that actually exports the C and the C++ interface API that can in turn be used by your Java code. So in the Hello World example, we really don't have the interface because we have not defined any, but let's go to the IPP example. There you can see that there is a hello IPP.c. So this is the C interface that can be directly used from your Java code. So there is also a Java part to it. So if you go to the source, there is hello IPP, and this is Intel making use of the C API that has been exposed there. So there are certain, so if you can see here, there is a load library call that is made, which will load the library and you will be able to use interface from your Java code. So what additional things have to be taken care to use IPP or the optimized library for the different operations that I explained earlier is you will have to add some of these definitions into your android.mk file. Specifically, if you note, ones that are really required for usage of IPP is the static library that will be used, which is the IPP Android preview, and the source file that is mentioned here. So this is the actual static library with all the function definitions for IPP within it. So you will have to link with this library to be able to use the optimized library functions provided by IPP. So you will have to mention these in your android.make. In application.make, here you can see that we are trying to build this only for the x86 platform, but you also have the option of building it for all. But then IPP optimization is again supported on x86. So you will feel or you will find the optimization taking effect on x86 platform alone. So running through the details of running through further details of what this IPP is, this is actually supported on cross-platform, or this is supported across different Intel platforms used in different form factors. So as you can see in the right-hand side block, this is supported on phones, tablets, ultrabooks, as well as servers. So IPP is supported on Atom, Intel Core, as well as Xeon processors. If you have intense computing functionality within your application, you can always leverage on the optimization that is done in the IPP library and take advantage of it. So this just explains in plain text of whatever I have showed you on Eclipse. You can use this as a reference whenever you would want to include IPP in your application. So one small exercise that you could also do is you can build an IPP version of your application and a non-IPP version of your application. And you can go back and use the GPA kind of a tool to really analyze the performance difference. So right now I don't have a non-IPP version of the application that I showed you, but then if you have a non-IPP version, you can always do that comparison. And what we have seen from the sample apps that we have ourselves developed, and also with a few of the partners that have used our IPP, that there is significant performance improvement by using the IPP library. This is again a snapshot of what needs to be done in android.mk file that I anyway have showed you using Eclipse. This is about, so when you install Intel IPP onto your system, by default you get the Hello IPP simple example that I have shown you. This describes in detail on how you can go about importing it and using it as a reference for your application development. So we have seen how to use optimized libraries so that your application also is optimized with respect to the underlying hardware platform. Now we will look at yet another application, yet another tool that will help you fine-tune the performance for different cores within a processor. So these days, whenever we look at any device, the devices are either dual core, quad core. So what does that really mean? So a core within a processor is an execution unit, and the more number of cores you have within a processor, the processor has the capability to execute multiple tasks simultaneously. But if an application is not really programmed in such a way to utilize or to leverage on this multiple core functionality, the cores are not used efficiently. So there will be CPU cycles that are kind of not used to the best advantage in the application. So there is yet another tool, which is Intel Threading Building Blocks, or TBB as we call it, which helps in really utilizing the multiple cores within the CPU in a very, very efficient manner. What is this Intel TBB? This is a C++ based template library, or an STL kind of an interface provided by Intel. How does it help? It helps by utilizing multiple cores, thereby speeding up the execution of different instructions within your application. That is one part of it. It also helps in reducing the power consumption within your application. The more cores that you utilize, the better it is for the power utilization within your application. So you can write performance optimized as well as power optimized applications if you use Intel TBB. This is an open, or rather I would say that there are two versions of Intel TBB that is available. One which is an open source version. There is threadingbuildingblocks.org, under which you can find the open source version of this tool. But there is also a licensed version that you can find under software.intel.com. So this diagram explains the different aspects of, or rather the different functionality that is supported by the threading building block. So if you are doing a lot of computation which can be done in general parallel algorithms or generic parallel algorithms, TBB is the best library to be used in your applications. Similarly, if you have concurrent containers, you can make use of TBB to really fetch data, store back data simultaneously. TBB also provides you with APIs for thread-safe timers. It also provides you OS API wrappers for even creating threads. So you can really make use of these and then ensure that different activities which are not really dependent on each other execute in parallel, thereby increasing the efficiency of your application. There are different wrappers provided for mutex operations and also conditional variables. So TBB exports or exposes a library which kind of abstracts all these functionalities within its APIs. I can again go back to Eclipse and show you a sample where TBB is utilized. Again, TBB is a C++ library, so for you to be utilizing TBB, your application has to be an NDK application. So we again go back to the JNI folder, which indicates that this is already an NDK application. And when I open the android.mk file, very similar to what I showed you in the case of IPP, there are multiple defines that are available here, and each one of these indicate that the TBB library is being used. And if you see here, we say that one of the libraries to be included is the libtbb.so. So once we include this, it is an indication to Eclipse that we are going to make use of the TBB library, and you can go ahead and use different functionalities of TBB. So there is also, this sample is also provided along with TBB when you download it. And in the application.make, here you can again see that it has x86 under app_ABI, and app_STL, we will have to this is the general STL library on which TBB is dependent on, because TBB in turn is also a standard template library. So in summary, if we look back, I have spoken about 4 different tools that are available for efficient development, profiling, performance optimization, and fine-tuning of your applications based on the kind of functionality that you are making use of in your application. All these tools, along with certain other tools, are provided to you in a single package by what is called the Beacon Mountain. Beacon Mountain is a tool suite that is available on software.intel.com. It's a comprehensive development environment specifically for native Android apps, but this is not restricted to native Android apps. You can even go ahead and develop Dalvik-based apps with this tool suite. One thing to notice here is this, even though I have spoken a whole lot about Intel x86 and Intel-based hardware platform, this particular tool is available for both Intel as well as ARM platforms. So you can use some of the tools here for ARM as well. So here there is a list of applications that are developed within Intel, so that is what I have covered as of now. There are also a list of applications that are used from third party, or rather we have borrowed from a different vendor. So as you can see, the entire Android ADT bundle is available when you actually install Beacon Mountain. Similarly, the Eclipse IDE is available to you when you install Beacon Mountain. Android Design, which is again a standard tool by Google, is also provided to you as part of Beacon Mountain. So in summary, for making your development process efficient and to enhance the user experience by providing better performance to your applications, you can use the Beacon Mountain tool suite for your development process. So this is what I had as a presentation. These are the contact details, so you can either contact me or Nalina if you have questions about the different tools that we have spoken so far. Now I will open it up for questions. Thank you for your patience listening.
Thank you so much, Suprabha. Just give me 1 minute. I'll start assigning you the questions. The only thing is that I need to type out the questions for you and Nalina to view it on the chat window. So allow me some time.
Sure, Srilagna. So here we have the first question from Bhavin. I read out the question. How thread building block is different from the normal thread concept in open source? Conceptually, it is pretty much the same. This is just go back to the CBB slide. In addition to the thread library, there are certain other functionalities that are kind of wrapped up within the thread building block, be it the thread safe timer API or the wrappers around the mutexes and conditional variables. These are certain additional things that are available along with the concept of threads. So there is also support for TLS, thread local storage, as part of the TBB library. I'll move on to the next one. How can, this is a question from Amar Bahadur. How can we use IPP to non-native apps? Sorry, Amar, we cannot use IPP with non-native applications. So even though we say this is a native app, there is not really a whole lot of complexity added to it. Like I showed you, all that you need to do is enable the native functionality onto your app, and you can include the IPP library out there and make the appropriate calls, JMI calls, still from your Java file. So this is not available for Dalvik applications, the IPP functionality, but if you want to still go ahead and use it, all that it takes to do is just enable the native functionality and start using the IPP underneath. Next question is from Divik. For developing, does it matter if we are using SDK version or NDK version? Our question was not really very clear. I'm not sure if your focus is really on the version of SDK or NDK. Okay. So if you are talking about whether you are using whether you have to use NDK or SDK, that really depends on the kind of application that you are trying to develop. So if it is something which can be really done using just the Dalvik API, then an SDK version of the application is what is required. But if it is really compute intensive, graphics intensive, then you may really want to consider NDK version of your application. Next question is from Heyman. How can I make an Android app with Beacon Mountain? So the process or the procedure of development is very much the same as the normal Android SDK that you use from Google. So like I mentioned, Beacon Mountain includes the Android SDK bundle as well as the Eclipse IDE when you install it on your machine. So the procedure is very much the same, but if you want to take advantage of the additional tools that are provided by Intel like IPP or TBB, then you will have to do the extra things that I have described in my presentation. Next question is Manoj, is from Manoj. The question is, I am a Java programmer. Shall I read Android for future good? That really depends on whether you would want to make a transition to Android development. But the world is, today's world is moving towards mobility with full force. I think it's good for all of us, all software developers, to learn Android. That's my personal opinion, but the decision is still yours. Question from Vinod. How can we use TBB to fine-tune app? Can you please repeat it? So like I mentioned earlier, there are multiple cores within a processor, And the different cores are best utilized only when your application is able to do simultaneous operations. So each of these cores are different execution units, and they are independent execution units. Only if you are able to use the different cores and threads supported by the underlying CPU in an efficient manner, you are making complete use of the processor. If you are still running a single-threaded application on a quad-core system, there are certain things at the system level that are kind of distributed to the 4 cores, but your application is not making best use of the different cores and threads supported by the processor. So to make best use of the underlying cores and threads, you will have to use TBB. But if your application in itself is very sequential in nature, and if you cannot do too many parallel things, one example that I quoted earlier was, if you are doing intensive data read and data write, you can see how much of parallelism you can introduce, and TBB provides you with API with which you can make this operation really parallel in nature. But if your application in itself is inherently sequential, TBB is not the best library to be used. Next question is from Bhavin. In my opinion, when configure IPP library with OpenCV, the directory and the bin should be ended in .dll. But why the directory of IPP library I download from IBM official website is that? I'm not really sure about the IPP library that you're using from IBM, but if you download the Beacon Mountain tool suite from Intel website, software.intel.com, you will get the IPP library. You will have to include it as a .a, in fact. This is a static library which you will have to include it in your application. So this is, to me, this is neither a DLL nor a .bat. Next question is from Amar Bahadur. How async task and handlers in Dalvik development are similar to TBB? So async task, or the kind of task mechanism that is supported by Android, is what we call the cooperative multitasking, where actually a task relinquishes itself and gives control to another task to execute or to really take cycles from the CPU. But the TBB is more of a threaded the library with which you can introduce parallel operations within your application. So this is not really similar to task, because at a given point in time, only one task can be executing on your processor on an Android system. But TBB, if you're using TBB library and making different operations within your applications to run in parallel, then it is actually utilizing multiple cores within the CPU. Next question is from Santosh. I want to learn Android app development. Suggest the steps to proceed. As a first step, I think you can download Beacon Mountain from software.intel.com. That's a comprehensive tool set that you can start your development with. It also comes with extensive documentation on how to go about developing Android applications. So go ahead and try it out. Next question is from Bhavin. What is .mk file? This is very much equivalent of a make file if you are more familiar with the Linux environment or the Unix environment. So this just contains instructions on what is the kind of build configuration that you want within your application. Oh, this seems to be the last question. Any more questions, Srilagna?
Yeah, there are more questions coming in, Suprabha. I'm just sorting them out and passing it on to you. Give me a second.
Sure. Take your time, no problem. So next question is from Vinod. The question is, I'm developing an Android music player. I'm stuck in between. Can you please help me out with some source code sites? Beacon mode. I'm developing an Android music player. I'm stuck in between. So I'm assuming that if you're talking about the NDK applications, I can really give you quite a lot of information about how to go about using the NDK API, how to go about porting existing NDK API onto x86 using the Beacon Mountain tool suite. But then generic music player, I think those, we do not have specific information, but then we can check and get back to you if we can provide you with details. Next question is from Sundar Rajan. How to start NDK development in macOS? Let me pass this on to Nalina. She is our NDK expert.
Thanks, Prabha. So, developing NDK application on Mac OS. Okay, first step will be download NDK onto for the different versions which is available. Like you are doing it on developing it on Windows, you are developing it on Linux machine. So there are different versions. So just go to the android.developers.com. So that will give you the step-by-step procedure for NDK development.
Yeah, the next question is from Bhavin. Is there any ARM equivalent of Intel IPP? Not that I'm aware of right now, but I can still go back and check with the IPP team if there are any plans of developing it for ARM. Next question is from Vikas. Is there any certification for such development? Okay. That is in Intel Android APIs. So if you are looking for Intel Android certification, I don't think we have such programs right now. Let's see how the future shapes up. Next question is from Jagatesh. I have a question about Android graphics into an app. I think we are missing the question. Jagatesh, my request to you to really provide us or send us your question. Next question is from Ranganathan. Can you please brief on Android DRM implementation, a sample code or reference site? Digital rights management, this is a pretty complex topic in itself. I think we can talk for an hour or two about it. So this is not something very specific to what we have covered today, because the focus of today's discussion was more on Beacon Mountain and the different tools that are available for developers for building applications more efficiently and effectively. I think you can look up to Google Docs. There is quite some information that's available to developers from Google itself. Next question is from Sundar Rajan. I have Android ADT installed in Mac but cannot get the path of NDK. May I know how to get this?
Oh, you have installed right now only Android ADT. So you have to install NDK separately. So it's not coupled with ADT. So there are two different entities. So you need to separately download NDK from Android developers.com.
Next question is from Amar Bahadur. In PBB, how they share data if two tasks are mutually dependent. So we have talked about OS wrappers provided for mutual exclusion. So you must be able to use mechanisms like mutexes and semaphores for sharing your data across two parallel tasks.
One or two more questions you can take up. I'm just sending it across.
Sure. So next question is from Manoj. How can we connect Android in Bello? Is there any process? I'm not really aware of Bello and what it is with respect to Android. So you can send me and Nalina an email with a little more details and we can get back to you. Next question from Chaita. These days Android market is most booming part. Can you please give me some idea about Android market after 5 to 7 years down the line? So if we look at how things were 5 to 7 years back, nobody would have predicted that the mobility market and the Android market would be where it is today. So similarly, it's too difficult to really make any statements of how things would be in 5 to 7 years from now. But I would definitely like to say that the tablet, the phone, the Android industry in general is pretty dynamic in nature. Bhavin, question from Bhavin. The question is, when will ICC or IPP be supported for all Android development? I'm assuming that your question is, when will IPP be supported for all different platforms? Like I mentioned earlier, as of now, it's not available for platforms other than x86. We will anyway get in touch with IPP team and let you know if there are plans of supporting it on other platforms as well. Question from Jagdatesh. How do I tune my Android app? So the last two tools that I spoke about in my presentation, the IPP and PBB, are two tools that you can use to fine-tune your applications for performance as well as power consumption. As in, you can write power performance as well as power optimized applications using these two tools. Another question from Jagatesh. How do I see the error after compiling Android apps? That's very much visible on your Eclipse console. Next question is from Amar. If I want to load a DLL of printer, then how should I proceed? So in Android, there is no concept of DLL. You either have a .so or a .a. So you will have to get the printer driver which is supported for Android platforms specifically before you can go ahead and load them onto your Android system.
We are running out of time, Suprabha. We do have a couple of more questions, but if I could request you to take them offline.
Sure, Srilagna. So,
And request you once again,
request
request you once again to share your email IDs, yours as well as Nalina's back up on the screen so that the attendees can take a note of the same.
So these are our coordinates. You can reach us on these email IDs and Twitter IDs. Feel free to come to us with any unanswered questions that you may have for this session.
Thank you so much, Suprabha, and thank you so much, Nalina. I'm pretty sure it was a great presentation and quite an insightful one. And as I mentioned, those who want to take up the questions with either Suprabha or Nalina, please feel free to email either of them, or you can reach out to us by emailing directly. The recording of today's session will be available on techgig.com tomorrow afternoon, so please feel free to log in and take a look at the presentation once again. And yes, thanks once again for taking time out, Suprabha, yet again today and giving this presentation, and look forward to working together once again in near future. Thank you so much, Suprabha and Alina.
Thank you, Srilagna, and thanks everybody for having attended this session. Thank you.
Thank you.
Bye-bye.
Thank you. Have a great day.